Okay guys, let's have a little intro for this section here on straight lines, quadratics and inequalities. The first thing to mention is about straight lines. The standard form of an equation, a straight line, as an equation is y equals mx plus c. That's the equation written in standard form. Then it's just simply a matter of reading off the number of x's, and that's the gradient. And then when you have it in this form, c is called the intercept. Yeah? Okay, so there's the intercept. So if you have, like, for example, y equals 2x plus 3, that would be, there's your gradient 2, your intercept is minus 3, so it would be very easy to sketch it. You'd have a gradient 2, intercept minus 3. The intercept is where the line cuts the y-axis. So it's the height above the origin on the y-axis that the line cuts the line. And here it's minus 3. We're told it's of gradient 2, so it's positive slope and it's fairly steep. So for illustrative purposes, we generally don't draw it strictly as steep as it should be drawn. But this is just an illustration. And then we label the straight line y equals 2x minus 3. Okay, so I hope you can see that. Now, if we did another line, by way of example then, let's just do another one. And let's just change it. So what are we going to do now? Let's do, say, minus 2x plus 7 then. Again, we do a little sketch. 0, xy axis. Here, the intercept is 7. So we'd mark off 7. And the gradient is minus 2. So it's a negative gradient. That means you stood here. You stood on this xy axis, facing in the forward positive direction. You want to draw a negative gradient. That means it's going downhill. The 2 is quite large, so you'd want to draw a line that's fairly steep downwards. Not necessarily as steep if you're doing the graph plot, because it's just a sketch, so you just want to illustrate it. So there's the line there. It intercepts at 7. And the other way to talk about the intercept is if you inputted the value x equals 0 on this. The input 0, this minus 2 times 0 would be 0, so the output y would be 0 plus 7, which would be 7. So that's the coordinate there. And that would be a coordinate 0, 7, of course, and that's the intercept. So the x-axis can be thought of in terms of this equation of a line as inputs. The input values you put in, and the y-value, coordinate, you can think of in your mind's eye, notionally speaking then, as the output. So you've got input, output, and they arrange a series of plots which form a straight line. For any input you get an output, according to this rule. So that's straight lines then. That's probably most of there is about straight lines. So as I say, that's the general form of writing a straight line. If you're given a straight line and told it goes through a coordinate, say this line here goes through the coordinate 1, 2. And it asks you to find, well, let's just say it goes through the coordinate, and it has gradient equal to 3, say. Now we can find the intercept. What you do is you input this line here goes through this point. So when x, the input is 1, the output y is 2. We know m is 3, so we'll be able to find c. So I'll just illustrate that for you here. So y is 2, m is 3, so we could write that in. The x is 1, so we could put that in, plus c. So that tells us then 3 ones are 3. Move the 3 through the equals. So 2 minus 3 then will equal c, won't it? And we'll get c equals minus 1. So we could draw the line then, because we can write down the equation of the line. Y equals mx, m is 3, plus c, c is minus 1. And the sketch then would be 3x minus 1. The intercept is here at minus 1. The gradient is 3, so we want to draw it fairly steep, don't we? Like so. Label it y equals 3x minus 1. Put the origin in, put the x-axis in, and the y. And typically that's how we draw a sketch. Okay, and that's basically all there is to straight lines then. More or less, a few variations on the same theme, but that's the essence of it. Quadratics is the next thing I'd like to mention about. So we'll keep that equation up there then, that we've got there. And now let's have a look at quadratics. Now characteristically, a quadratic written in standard form is written as y equals ax squared plus bx plus c. That's the equation of a quadratic. A is non-zero, of course, because otherwise we're back to straight lines. So that's the general form. A is a number, any number, B is a number, and C is a number. Now, if A is positive, we have a U-shaped curve. And if A is negative, we have an N-shaped curve, and that's it. So you draw a sketch, but you need to find the roots. To do the sketch properly, generally you need to find the roots, and in this section I'm just going to use the formula most times, almost always. And the formula here is minus b plus minus, as we probably know all too well, b squared minus 4ac all over 2a. That's the formula for the solving a quadratic equation, isn't it? So we'll use that formula by and large, just to quickly ascertain what the roots are. Let's suppose then we found roots of 1 and 2, and we had a was equal to 3. Let's just suppose that. So we looked at the a, we found it was 3, which was positive, and we found out the roots by solving this quadratic, and we got them to be 1 and 2. Generally then what we would do, we would mark off the roots 1 and 2, and then a is 3, so it's positive. So positive, it's a U-shaped curve, so then we could sketch if I can sketch it properly, of course, it always helps. So we can sketch our curve like so, going through those two roots. The only thing of interest, oftentimes, is what value is it when x is 0. So that might also be a potential value that might be helpful to see how steep you'd need to draw this line here. And it's simply obtainable very easily by just inputting x as 0, and you get y equals this value here. Okay, then the c value is when x is 0 for that quadratic. Okay, that's quadratics then. That's all there is to it. Roots, and is it this dominant term, positive or negative? Because this dominates when x is large, positive, large, negative, and that's why it eventually swings up both sides, or if a is negative it will swing down because this term predominates for x being large values, either large negative or large positive. Okay, then that's quadratics. So the only other thing I want to mention is about inequalities. Couple of little things on inequalities. So y equals a x squared. So I'll leave that there. Remember what we said? A was positive. It was a U shape. And the other thing was a was negative, and it was an N shape then, wasn't it? And we get the roots. And we need the roots, and we use the formula, which I'll write down every time anyway in the section. I might put it up at the end of this little thing. Inequalities now. So if I said to you, you got the straight line y equals 3x plus 5, say, and we could draw the straight line. We know it's intercept 5. We know it's gradient 3, so it's fairly positive and steep. So we'll just draw that in like so. Now, if we change this equation to an inequality, and instead of having equals, we had less than or equals to, what that then tells us, this line is fine, but it tells us the heights that y is satisfied by this inequality. So it's all the heights less than what values happen at the line. So there's the line itself. So everything underneath that line is here, isn't it? All these values in this region, the x and y's, for the x's, all the y values are underneath the line for each x value. So that entire region is denoted by this inequality here, because it's underneath the line, like that point there. That x value, the y value, is less than the y value that's on the line. Notice it's a solid line because we've got less than or equal to. If we had a less than, there's another notation we generally use. So let's just quickly give an example of that. So suppose we had y is greater than x plus 1. Nice and easy. So if we wanted to sketch that region, we draw the line y equals x plus 1. But because it's greater than, generally the intercept is 1, gradient is 1. But because it's greater than, it's not going to touch the line. So we use a dashed line to denote that, the fact that the values don't touch it. The heights here, the y are the heights, the outputs, are bigger than what happens on the line. So again, if we look at it, you can see that that side now, above the line, so for that x value, for that input value, the output is above the output you'd get on the line. So that region, that point is in the region satisfied by this inequality. So there's the entire region then, above the line, isn't it? So there's the notion of inequalities. It applies both to straight lines and to quadratics. The only difference is you'd have it above the u or below the u. It might go up to touch, so it would be solid, or it would be a dashed if it doesn't touch. So that's the same notions with quadratics. One little thing I want to say just to finish inequalities off before you have a go at the questions is inequalities like this. X is bigger than 3, say. If you're doing x is bigger than 3, the value of 3 on the x-axis is bigger than 3, so it doesn't touch 3, so we need a dashed line in that case. And bigger than, everything to the right here, any coordinate here has an x value that's bigger than 3, doesn't it? So this entire region, if it was bigger than or equal to, we'd draw a solid line down here, wouldn't we? Because it can go down and touch the values here. And any coordinate on this line also satisfies this inequality. So less than, of course, would be on this side of the line, the smaller side. And again, same with y. These are the heights, you can think of them as. So y is bigger than 2 and equal to 2. You draw a horizontal line at 2. Everything above, any coordinate above the line 2 has a y value bigger than 2, or equal to 2, like that coordinate does. So again, it would be the entire region up here, wouldn't it? It would satisfy that inequality. So there's several questions on inequalities. It's only a matter of drawing the regions in question and seeing what region pertains to all the respective inequalities, what region is left defined by all of them together. Okay then guys, all the best in this section as I say. Let me just write down the formula at the end for the solving quadratic, finding the roots. This is what we use for the most part. Sometimes if it's very easy we'll just move things around, but this is generally what we use. So I use that a few times to avoid any confusion. Okay then guys, all the best with it, and I'll catch you again in another section. Cheers!